Hello, prob stats, and welcome to 9.2. Again, very similar to Chapter 8. This one here is about two populations with means, and we will compare the means between the two populations. All right. Make sure you have stat disk open. You'll need it, and let's go. All right. When you are looking at these different ones, we have to distinguish between independent and dependent, not independent. We are going to make a hypothesis test about two means. And we are going to construct confidence intervals. Nothing different than we've done in the past. Now remember the difference between independent and dependent. So independent is if the sample values from one population are not related, all right, in any way, shape, or form. All right, they are not naturally paired or matched with anything involved. Dependent means just the opposite. The sample values are somehow matched, and they're where the match is based on some inherent relationship. So maybe they're brother and sister. Maybe it's one person and you take their temperature in the morning and night. Something where they're matched together. Now, again, your notation is the same as it was last time. All the ones refer to the first population, and then all the twos will refer to the second population. Okay, the requirements for our mean is that the standard deviation of the first and the two are unknown, and we do not assume that they are equal. All right, they have to be independent, simple random samples, nothing new here. And this time, this is an either or. So either they're both over 30 or they have a normal distribution. So if they're not over 30, they have to have a normal distribution. If they are over 30, they can, but nobody cares. All right, so it's either or, not both. All right, we do have another calculation for calculating the test statistic, but we'll be using stat disk instead. Again, it's just your sample, your means from 1 and 2 minus your population means all over your standard deviation squared over how many you have. Nothing too difficult, so you could do this at home if you did not have stat disk with you. I'm hoping that is not the case. Degrees of freedom is the same. It's N1 minus 1 and N2 minus 1. They will both have their individual degrees of freedom, are the smaller of the two. Okay, technology, we will use degrees of freedom, and it has this great big calculation. We will not be using that. We'll let technology do it for us, or if we have to do it by hand, we will do the smaller of the two. The p-value, critical value, and confidence interval will all be found by stat disk. And this time what's nice is all three of them give us the exact same thing. They are all equivalent in the sense that the results are the same conclusion. So all three reject the null, or all three fail to reject the null, unlike the proportion. All right, here is our example. We have male professors and female professors. We have their ratings down below. Okay, this is how student course evaluation scores for them. Between the female and the male professors, we want a 0.05 significance level to test the claim. We want to know if there appears to be a difference of evaluation scores of the courses taught by female professors and male professors. So you need to type these both into stat disk. You will need to do your data assessment and get your means, and then fill in the bottom. So pause and do your work. All right, I hope you got that typed into stat disk okay. So your first requirement is the standard deviations have to be different. So when you type those in, you should have got 0.563 and 0.395. So they're different, that checks. They're independent, they're male, female, they do not rely on each other. They were simple random samples. And when you check for normality, you might have had a little trouble when you looked at the histograms because the female one did not look normal or a nice bell shape. But if you use the Ryan joiner, they both passed, so all four requirements are met. So step one, we let the mean of 1 equal the mean of 2. The original claim is that they're not equal. So our null hypothesis is mean 1 equals mean 2. The alternative is they are not equal. We have a significance level of 0.05. And now we have to do the two populations means using the t distribution. So you're in stat disk and you go into analysis, and this time you're doing two samples means. All right, instead of writing this all out. I have it on the next page for us. All right, so here's our hypothesis testing. This is what you typed in, not equal to for our alternative, 0.05. We had 12 female, we had 15 male. We put in their mean and their standard deviation and hit evaluate. Okay, when you did this, you should have gotten a test statistic as negative 0.65959, your critical T, a positive -2, your p-value of 0.51740, degrees of freedom was calculated by StatDisk, the hard way, and our 95% confidence interval is right here, which does include 0. All right, let's look what we got here. If we're using the, p-value, all right, because the p is greater than 0.05, we reject the null, which if you look from above, p was something large, 0.5174. So it was really large this time. So 0.517 was greater than 0.05. So we failed to reject the null. So right now we cannot do this. There is not sufficient evidence to warrant rejection of the claim that female professors and male professors have the same mean course evaluation. So we're saying they're different. All right, now let's look at the critical value. If you look here, we had our test statistic was negative 0.65. We have our critical value of negative 2 and 2. Our rejection regions were down here because it was a two-tailed test. Our test statistic did not fall in there, so again, we failed to reject the null. Now let's look at the confidence interval. So we're looking to see if 0 actually falls in our interval, and it does. So we are 95% confident that the limits of negative 0.53 and 0.27 do actually contain the difference between the two populations. All right, because those limits contain 0, this part right here is important. This confidence interval suggests that there's significant difference between the mean course. So since there's not significant difference, we also reject the null. All three had the same result. All right, good luck on your homework. I hope you do well. And remember, no work day again tomorrow.